Okay, so I just made the video on parallel and perpendicular lines, and in class I had mentioned that I also wanted you guys to work on your graphing of basic functions in your book. And the ultimate goal is for you guys to be able to graph about 8 or 10 different functions. They're all in your book, and they're actually on the wall in our classroom that you've all seen. And then be able to find their domain and range. I'm sure you've all done it before, and if you haven't, I want you to actually practice it. But I figure I would do one or two here, the simplest ones, and then you guys can do the more complex ones. And I'm aware this might be rather boring, but oh well, it's what we would have done in class anyway, just for practice. So say we'll start with a basic one that you all know, y equals x squared. I know you all know what the graph of that looks like. Again, the idea here is understanding how to graph things when you don't know what the graph looks like, and then finding all the properties of the graph. So suppose we have y equals x squared, and we want to graph it. Pick x values, and then plug them in to get your y values. So really quickly, because we all know this one, if x is 0, 0 squared is 0, so y is 0. So you get the point 0, 0. If x is 1, 1 squared is 1, y is 1, so you get the point 1, 1. If x is 2, 2 squared is 4, y is 4, so you get the point 2, 4. And now, of course, it goes up like this, just like we all know. If you plug in negative values of x, if you plug in negative 1, negative 1 squared is positive 1, so at negative 1, you get positive 1. If you plug in negative 2, negative 2 squared is positive 4, so at negative 2, you get positive 4. And then assuming I can draw reasonably straight, it'll just go up like that, and we get the parabola that we all know. Again, I know we know the graph. I care about your ability to graph things in general when you don't know what they look like. But then as far as it goes, once you know a function, in class we had said you need to know the domain and range. And we had said we wouldn't care about the range until we actually got to graphing. So since we're working on graphing now, we can look at the range. As far as this one goes, the domain of f, the domain of the function, what x's can I plug in? Well, all of them. I can plug in any number I want and I can square it out. So the domain will just be all real numbers. As far as the range goes, the range is all the y values you get out of the function. There are different ways to do this. You can just look at the graph. One way that a lot of people use is do the horizontal line test, essentially. Take a pencil, take a ruler, whatever. Look at all the y's that get touched. None of these get touched. The first y that gets touched is 0, and then everything up here will get touched too. So what's my range? Everything from 0 up to infinity. So closed interval brackets, because we're including 0, and then all the way up to infinity, open, because it's infinity. And there's my domain and range. There are a few other properties to this graph that we can't really go over just yet, because we don't have definitions that we'll get later in the semester. So when we do that, we'll come back to this graph and kind of expand on it. But for right now, as far as your graphing goes, I care about your ability to graph a function and then tell me the domain and the range. So, maybe one more, because I want you guys to do most of these for practice. So if we did y equals x squared, we might as well look at y equals x cubed. And do the same thing. Let's see, pick values of x and plug them in. If x is 0, y is 0 cubed, which is 0. If x is 1, 1 cubed is 1, so y is 1. If x is 2, y is 2 cubed, 2 cubed is 8, so at 2 we get 8. At 3, y is 3 cubed is 27, which is like somewhere up here on the wall, so I won't do that because my wife will get upset. So we just know it'll get really big really fast. And they'll kind of go up like that. If we look at negative x's over here, if I plug in negative 1 cubed, keep in mind there's 3 negatives there. An odd number of negatives means it stays negative. So at negative 1, I get negative 1. So I'm actually down here. If I plug in negative 2 cubed is negative 8. It stays negative. It's down here. And again, much like the square, we can kind of see what's going on. It'll just shoot down there. And you get that elongated thing. Students in the past have called it an elongated S, whatever you want to call it. That's the graph of the cubic right there. Again, then once we have the graph, we care about the domain of the function and the range of the function. What's the domain? What x's can we plug in? Well, I can plug in any x I want and I can cube it. Nothing causes the problem, so the domain is clearly all real numbers. What's the range? Well, if I do the horizontal thing again, in this case, everything down here gets touched because that goes down forever. Everything here gets touched, and it keeps on going forever. Which means every y value gets touched, and the range is also all real numbers. As far as it goes, that's the only two that I am going to graph, because I want you guys to practice these to see how they work. But I had mentioned in class the ones you should know. You all know how to graph a line, y equals mx plus b. Slope, intercept, good to go. You can all graph horizontal lines and vertical lines, no big deal. We went over the square graph and the cubic graph. Let's see. You guys should be able to graph the square root graph. You should be able to graph the cube root graph. You should be able to graph the absolute value graph. You should be able to graph the greatest integer function. I think your book writes int of x. Different books write it differently. I think that's how your book does it. Let's see. What else is there that we need to know? Square root, cube root, absolute value, greatest integer function. That's all of them that come to mind right now. We might expand on that in class. There will be a few more that we'll learn later in the semester. But I want you guys to be able to graph all of those, and then also from those graphs find the domain and the range. And you need to have the graphs memorized, because the ultimate goal that we're working towards is being able to take something like y equals -3 times x minus 2 squared plus 7 and graph that in about 5 seconds, which is what you should be able to do. But you won't be able to do that until you have all of these basic graphs memorized. And then in class on Tuesday, we'll kind of expand on it and start working on that right there. I'll post homework later today that will be from your book to let you practice with all of this graphing stuff. And since I'm finishing up my videos right now, I do have to thank my daughter, who has been nice enough to actually sit through all these videos and videotape them for me. And that's it. I'll see you in class on Tuesday.